For a timber beam that has an elastic modulus of 12 gigapascals, we want to find the slope at A and the deflection at the midpoint C. The cross-section of the beam is a rectangle of 50 by 150 millimeters. This is the second example for the bending deflection video. So if you haven't watched that one or the first example, make sure to check out the links in the description of this video. The process will be the same that we used during example 1. Since for the slope and the deflection we need the second moment of area I, we'll calculate that first. The value for the term EI that we need in the denominator will therefore be 168.75 kilonewtons meter squared. Since the reaction force at D is located for x equal to 2, and therefore that term will always be 0 in the V of x equation, what we really need is the reaction at A. So the only statics analysis we'll use is the sum of moments about D. The distributed load equation only has one term that begins at x equal to 1. The integral of the distributed load will have two integration constants, which are the reaction force at A and the point load of 4 kilonewtons. The integral of the shear force will not have any constants, as once again there's no external couples. We will write the equations for the slope and the deflection in terms of EI for now, since we have to find the constants C1 and C2 first. The boundary conditions are that the deflection at A and D are 0. From the first boundary condition, we find that C2 is equal to 0, and from the second boundary condition, we find the value for C1. For the slope at A, we can use the slope equation for x equal to 0, and for the deflection at the midpoint C, we use the deflection equation for x equal to 1. Thanks for watching.